this is Sneha and welcome back to my YouTube channel. In today's video, we are going to deploy our first ever Move smart contract module. So I hope you folks are excited. Just to give you a quick recap before this video, we have covered a couple of different topics, including setting up your Aptos developer environment, learning a little bit about Aptos' storage model, learning a little bit about resources, and how you can use the Move's 5 main global storage operators to interact with resources. So if you haven't checked out those videos, I would highly recommend that you go and check them out. I will link them up above. For today's video, we'll start right from Aptos' developer environment, where we had set up our file structure on VS Code. So yeah, do check that video out if you haven't, and we'll just take it up from there. So you know what? Let's get started. Right, so here we are in our VS Code repository that we had set up the very last time. So as I had described before, when we want to create a smart contract, which are again known as modules on Move language, we will be basically creating them under this sources subfolder that we see over here. So we've just created a file called hello.move over here. And right now this is a blank file. So we can just start off with like creating a normal skeleton of like what it would look like to write a Move module. First we need the module keyword over here. So this module keyword will be followed by the address of the deployer. So this can be 0x something over here. But instead of doing this, we'll be just writing deployer underscore address. We are basically setting this deployer underscore address in our Move.toml file over here. So instead of this, you can actually copy paste the 0x address and put it here as well, and that would work just as fine. But we are doing this, we are saving this as a named address like a variable so that we can later access it somewhere else in the code as well. And then we just need to modify it here from the Move.toml file. So now that we have the module deployer underscore address, this will be followed by this colon operator, which basically you can say is used more or less for inheritance in Move lang. So we are just saying that this module will be deployed under this particular deployer's address, and the name of the module is what we'll be writing over here. This is just going to be the name of the module. For today's video, we'll just be creating a list of like all of the Aptos Move based DevCon events along with a special attribute on whether you will be attending those events or not. So let's just name this something like DevCon events, and then this will be followed by this curly braces. So this is the basic skeleton. We can divide this basic skeleton into a couple of different parts. First, we will have all of our use statements to import libraries. This will be followed by some structs that will be writing structs and resources. And this also includes events. And then we will be having basically all of our functions. And this will be then followed by any sort of unit tests that you would like to write. Okay, so this is like our basic structure, and also this is how you can write comments on Move lang. So yeah, so since this is a very basic example, we can go ahead and then just import a couple of different things here. So if you see, I'm just using this standard std library. So this std library has all of the basic data types that we'll be using. And I think we will mostly be using a couple of these things. I think it's events, but it might be event, I'm not sure. So yeah, so we have this std, and then I said like we have this colon. So this represents like the signer. Signer, if you remember, I had discussed in a previous video, it's like a special data type that allows us to access the caller of a particular function or the account of a particular function, similar to message.sender on Ethereum. String and vector are just like two normal basic data types that we'll be accessing. And then this events is under the Aptos framework, which again contains all of main code that we'll be using later for objects, for tokens, for NFTs, all of that. So it contains events, which are basically just like solidity events that we'll be throwing whenever certain actions will be happening on our smart contract. Okay, so we are good to go. Now let's go ahead and create a struct. So we can say something like struct devcon event list, and let's say that it has a key. We will be storing the list of events over here. So if you observe this struct devcon event list, it only has this key ability. So as we had discussed in a previous video, any sort of struct which cannot be copied or dropped, so these are resources, meaning that this does not have the ability, to copy slash drop with it, so it just has key. Okay, so now coming back to this, we are just maintaining this events over here. We can maintain this to be a vector of defcon event. So this is a struct that we will define. Right now we haven't defined this yet, so this might be a bit confusing, but yeah, we just haven't defined this one yet. So yeah, so we have this events, then we can maybe introduce a event counter. We can keep this just a u8. I don't think we need more space than that for this one. And then we can create another struct which we'll call defcon event, and this struct will just have abilities key, copy and drop. So this one right over here, since this has the copy and drop abilities in place, this is not a resource. So let's just mark this as not a resource, and this is being done intentionally. Like, we want the defcon event list to be a resource which will be basically moved to our account, but we do not wish that the individual events inside the defcon event list should be resources as well, because this is like a list which can be edited and modified later on, right? So this copy and drop makes sense over there, so we should not be saving this without the copy and drop abilities. So yeah, so now we have the struct defcon event. We can maybe save an ID over here. We can save a name which can be a string type, description, spell that wrong, oh my god, okay, yeah, which can again be a string, and then we can basically just save like an attending, which can be like a bull, like a flag if you're attending it or not. So yeah, this can be basically our two main structs, right? So now that we have our two structs in place, what happens if you try to compile this code? So I just want to remind you of all of the abilities in Move. We have the key, copy, drop and store ability. And if you see this struct defcon event, which is presented as a vector under this, meaning that the struct defcon event is getting stored under this particular vector. So if you try to actually run the Aptos Move compile command, we will actually run into a couple of different errors. As you can see, this particular vector has the ability is being stored but does not have the ability store. So we need to actually add this to our struct so that it can be stored under this struct. And we also see this string error, which is basically us just maybe importing it wrong. So this should work just fine. Okay, so now we have our resource struct in place and not a resource struct in place. We can actually just go ahead and start writing on the functions. So let's start off with creating event list, and this can basically take in a particular caller, which is the signer, and yeah, I don't think we need anything else. So this is basically whoever is calling the function. We are creating an event list for that. So we'll be creating this resource and we'll be moving this under this caller's account. So, and we'll be using the move_to operator, if you remember, for doing this. So we can just do a move_to, and we'll have our first parameter as the caller, and the second parameter will be the resource itself. So it will be a defcon event list, and this will basically take the first parameter to be the events and then our event counter, which initialization, so we'll just set it as 0. But before we go ahead and do that, we actually need to check whether this particular caller has an existing resource of the same type, that is defcon event list, attached to it or not. So we'll just write an assert statement, assert exclamation mark, and we'll just do an exists, and we will just check whether the type defcon event lists exist at our caller's address. And you might ask, where are we getting this caller address from? So in order to do that, we will be using our signer library. So we can just do something like let caller underscore address is equals to signer address of, and we'll just pass the caller over here. So from our signer data type, we are able to derive the caller address, and the reason why we are doing that is because this exist function actually takes an address over here. It does not take a signer type over here. So we are just going to get the address and then check whether the defcon event list exists or not, and we don't want this to exist, so we're just going to add another exclamation mark at the beginning to indicate that we don't want this to exist, and if it exists, then we'll basically throw an error. So this is our condition. If the condition fails, the second parameter holds the error code that we'll be throwing. So we can just say something like 2001 as the error code for this. A better way to actually save this particular error code stuff is to like declare this as a constant. So we can say something like constant event list exists, and this we can keep of type U64, and we can just move this over here. Here, instead of giving this, we can write something like event list exists. So this syntax would also just work fine, and is better in terms of like readability, right? So we're just like doing a move to caller a defcon event list, and let's create an empty vector. So let's say event list vec, and we can just do a vector, and we can just do an empty vector over here of type defcon event list. So we are just going to create this defcon event, it's called a defcon event, and then we'll just move to caller defcon event list events, and this will be event list underscore vec with event counter set as 0. And let's just try to compile our code. Great. So our code has compiled successfully. This defcon events v1 that you're seeing is just the completed version for this. Okay, so now we have the create event list over here. Let's just copy this function. We are just going to write another function known as add event, which will take the caller and some more details like the name, description, and I think attending. I think we can maybe by default just take that to be like false. We'll do a similar check for exists, but this time we will remove the exclamation because we want a particular defcon event list to be present for our event thing, right? We will check whether it exists or not, and if it does not exist, you will actually throw a different error that event list not exists. So let's just write the error for that as well. Just gonna copy this. Not exists, and let's make this error code as 2002. Okay, cool. So now we have this assert statement in place. We are checking if it exists or not, and if it does, now we actually need to modify this vector and push our new defcon event over in this vector, right? Yeah, instead of doing this, we will just go ahead and borrow a mutable reference. So we'll just do a borrow global mute for defcon event list, add address, which is caller underscore address. Yeah, let's get that. We'll get the complete event list. And what we want to do is we want to modify our particular vector. So we just need to do something like a vector pushback and then pass to our existing event list. So it'll be something like @mute event underscore list dot, I think it's called events. Yep, we're just modifying this. So events, and here we'll just pass the new event. The new event we can just define over here. Let new event is equals to what all fields does this take? ID, name, description, attending, right? So this can be something like defcon event ID, name is name, description is description, and attending we can keep this to be false at the beginning. The ID field also, we will be able to get this from this event list because we have our event counter set which we had set to 0 at the time. Let new underscore ID is equals to event underscore list dot event underscore counter plus 1 and this can be new underscore ID. Okay, so we have our new ID which we are pushing over here. New ID is event underscore list plus 1, and we'll also we're just gonna go ahead and remove this line. We have modified our vector to include the new element over here, and also going to update our event list. And what we need to modify here is that we need to first of all get that particular vector item. So we can write something like let vector item is equals to vector. We'll be modifying it, so we need a borrow mute in this case. We're talking about defcon event, and vector list is at events, and we want this particular ID. So we can get the vector item in this way, and then we can go ahead and just set the attending to be true. There you go. And that's how we can mark this as true. Let's go ahead and compile. Again, we have the same acquires issue. We can go ahead and add an acquires for defcon event list. Go ahead and compile. Great, our code is compiled. Now let's also work towards writing some getters. Let's say get the event list data. So in move lang, after the name of the function and after the parameters, if you want to return something, you'll have to add a colon and whatever it is that you want to return. So now for this get event list function, we don't need to actually pass the signer. We want this to be somewhere where people can just pass an address. So let's just say something like attr address, and which is followed by colon, and they can get basically the vector list for the defcon events. And we can just, because we just reading, we don't need a mutable reference anymore. We can just do a borrow global insert. So we can say something like let an event underscore list and borrow global. We are borrowing from the defcon event list the particular address, and we wish to return just the event underscore list dot events. And if you notice, I'm not ending this with the colon because this is essentially the way that we can return things on MoveLang. So yeah, this is what my function looks like. I'm gonna go ahead and write another function, but this time I will be returning this by ID. Same thing, we'll pass address, but this time we're not getting the entire vector, but instead we're just gonna get a single struct. So let's just pass our returning data type to be defcon event instead. Here we can go ahead, do the same thing. Let event list is equals to borrow global defcon event list address, and we can then go ahead and get that vec item by doing a vector, and we'll just do a borrow. Again, we don't need a mutable reference for this, a borrow would work just fine. We'll just pass the list event list dot events followed by the ID, which I forgot to pass over here. So this can just be the ID that we want to access. Yep, so ID. Then we can just go ahead and return that particular vec item. We can add asterisk to this because I think the returning data type would not match with our defcon event. This might just give us a reference, so we will need to dereference this by passing this asterisk over here. So let's go ahead and then try to compile our code. So yeah, we have the same errors for the acquires. Just gonna go ahead, quickly add the acquires. I keep forgetting about this one. Acquires defcon event list. Okay, go ahead, compile. Okay, great. So this is our code which has compiled so far. So that was it for this video. In the next video, I'll be basically adding events to this particular contract and lots of work on writing some unit tests for this particular contract, modify this, and then get ahead with publishing this contract. So looking forward to seeing you for the next one. Take care. Bye.